Good morning. Now, this is a second lesson of chapter 1 of class 10 NCERT book, that is real number. And in this, we will study the fundamental theorem of arithmetic. Now, what fundamental theorem of arithmetic states that it states by it states that every composite number can be expressed or factorized as a product of prime, and their fraction is unique apart from the order in which the prime factors occur. It means that we can find the prime factors of any number. Means if we find the factors of number, they will come to be the prime factors. The order can be different, but it will always be prime factors. Let's take an example over here itself. It is 32,760. So we have to factorize it. We have taken 2. First we are dividing it with 2. 2 as a factor we are considering. It becomes this. Then again this is a even number, we are taking 2. It becomes this. Then again we are dividing by 2 as it is even, it becomes this. Now 4095. The smallest number by which it can be divided is 3. Because last is 5. Either it will be divided by 5 or by 3. Then next it becomes this. This is also last digit is 5. It can be divided by 3 or 5, the smallest number by which, though it can be divided by other bigger numbers also. So the number will be this. Finally, we get 455, which can be only divided by 5 and 7. So we'll divide it by 5 first. We get 91. 91 is divided by 7 and we get 13. 13 again is a prime number which cannot be further divided. The list of factors of prime number will be 2, 2, you can say it as 2, 2, 2, 3, 3, and further it is 5 and 7 and 13. 5, 7 and 13. These all are prime numbers. If I want to write them out, I can write 2 into 2 into 2 into 3 into 5 into 7 into 13. These are actually the product of primes. So any number can be written in this form, and when we compile them, we can write it as 2 raised to power 3, 3 raised to power 2 into 5 into 7 into 13. Now going further, we'll get some questions. Let's go to the questions. And first, let us understand what is the relation between HCF and LCM. For that, we'll work it out over here. First, we will understand what is HCF. HCF is highest common factor and LCM is least common multiples. Let's say there are two numbers. One is 42, another is 68. One is 42, another is 68. The factors of 42 will be 2 into 2. 42 is basically 2 into 3 into 7. Because 6 into 7 is 42. Whereas 68 we can write as 68 can be divisible by 2. It will become 2 is one factor. Further it can be divided by, the factors of 68 will be 2 into 2 into 17. Now if we talk about HCF, then we have to find the common factor, the highest common factor, and the only common factor between them is 1, 2. HCF will be 2. And LCM, if we want to find, then LCM will be the least common multiples. First multiple is 2, which is common in 2, which we can write just 1, 2. Other multiple is 3, which is not common but it is there, 3. Then 7. Then again this 2, which is left, 2, and then 17. The product of all these numbers will be its HCF, LCM. Now what is the relation between HCF and LCM? And LCM will be, if there are two numbers, let's say 42 and 68, then HCF of 42 comma 68 into LCM of 42 comma 68 will be equals to 42 into 68. That means any two numbers A and B, their HCF, product of their HCF and LCM is equals to the product of both the numbers. Now using this we will be solving the questions of your exercise. Now let's check out the first question. Express each number as a product of its prime factor. You can easily find the prime factors of 140. Let's say you have to find the factors of 140. There are many methods to do so. One of the methods which is given in book, like the way they have done. First, it can be easily divided by 2. 2 will be one factor and the remaining part will be 70. 70 can further divide it by 2. The remaining part will be 35. This 35 can be divided by 5. The remaining part will be 7. And 7 is a prime number, therefore prime factors will be prime factors of 140 will be 2 into 2 into 5 into 7. This can also be done 2 raised to power 2 into 5 into 7. And this will be your answer. Now going to the second question. Now in this, find the LCM and HCF of the following pair of integers and verify that LCM into HCF is a product of two numbers. This I have already explained you. You can find the LCM and HCF by prime factorization, and then you will multiply those LCM and HCF and multiply these two numbers and verify whether the product of two numbers is equals to the product of LCM and HCF of those two numbers. Similarly, you can find the LCM and HCF from these three numbers. Just find out the prime factorize. Let's do the first question if you want. In third question, first part, we have to find the LCM and HCF of 12, 15 and 21. The first thing which we need to do is we need to find the prime factors of these numbers. Prime factors of 12 will be 2 into 2 into 3. Prime factors of 15 will be 3 into 5 and 21 will be 3 into 7. The common multiple between all three is 3. The highest common multiple between all factor between all three is 3. The answer will be HCF will be 3. And LCM will be all the factors. 2 is there. 2 into 2 isn't common. Then 3 is common in all. Then we'll take 1 3. Then 5 into 7. Answer will be 22, 4, 4, 3, 12, 12 into 5, 60, 60 into 7 is 420. 60 into 7 is 420. Next, given that the HCF of 306 and 657 is 9, find the LCM of this. As it is, you know that HCF into LCM equals to product of two numbers. This is what known to you. And HCF of these two numbers is given 9 into LCM. I'm showing it on screen. You know that HCF into LCM is equals to product of these two numbers. HCF is given 9, LCM we have to find, and product of two numbers is 306 into 657. LCM will be equals to 306 into 657 upon 9. One of this number you can divide by 9, either this one or this one, and you'll get your answer. You can divide this 9 3 is 27 and then 4 34 into 6, 57 you have to find. LCM will be 34 into 6, 57. You just need to do the calculation. Now coming to this question, check whether 6, this is actually 6 raised power n, not 6n. It is printed wrong over here. It is basically 6 raised to the power n, and you have to find whether this will end up with 0 or not. Now how you will get to know whether this will end up with 0 or not? It's very easy. The number which ends with 0 are those numbers which have a factor of 10 or which is a multiple of 10. Only those number ends with 0. Rest of the number do not end with 0. So what we will do, we'll check it out whether this also ends with 0 or not. So if this has to be end with 0, this should be a multiple of 10 or it should have a factors of 10. What is the factors of 10? Factors of 10 are 2 and 5. You have to find whether 6n ends with 0 for any value of n, and if we are putting any value of n, then 6n will end up with 0. This we need to find. So the factors of 10 are 2 and 5. If 6 has both the factors, if any number has both the factors, that number will surely end with 0, whatever it has the power. But if it do not has any of the one factor, it will not end with 0. Like in this case, 6 has a factor 2 into 3. 6n will be having a factor 2n into 3n. This shows that 6n do not contain 5 as a factor. Therefore, 6n will not end with 0. 6n will not end with 0. Now, if you take some other number, which will you have to find whether it will end up with 0 or not, then it should have one factor of 5 and one factor of 2 also in it. It might have many other factors also, but two of the factors should be, one should be 2 and other should be 5, except that there could be many other factors. Now this sixth question, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. Just first calculate the number out of this in both the terms and find out their factors. If it has only two factors, one itself, another is 1, means if it has a factor of itself and 1, then it is a prime. And if it has more than two factors, more than two prime factors, then it is a composite number. You will get more than two prime factors of both of these, so you can say that it is a composite number. Over here, there is a circular path around the sport field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at starting point? How you can find the answer? Simply, one is taking a round around each other. This is a circular path. One has started from this point. The another will start moving on this same track with little slower speed. And finally, they both will meet at some point. So let's say the blue one started fast and completed one round in 12 minutes, that is Ravi, and he was somewhere over here, whereas after 18 minutes the Sonia completed this round. By the time the Ravi has completed another half of its round. Then again they have taken that this way, they keep on uh, taking the rounds and all. Now how many rounds Ravi will be taking and Sonia will be taking? So finally there are some, they can meet together at same point. This can also only be happened with the common multiples of these two numbers. See, this is first time they take around, she also take around. Another time he takes around, she also takes around. This is how we are finding the multiples of these two numbers. Wherever the both multiples come together, that is the answer. So what we have to find in this question? We have to find the LCM of these two numbers. I hope this is clear to you. Now moving to the next one. Now the next topic is revisiting irrational number. Now in this you have to show that each of this, which we know that they are rational numbers, under root 2, under root 3, under root 5, we have to prove that actually it is a irrational number, not a rational. Because how we get a decimal value which is non-terminating, so we have to prove that this is irrational. Basic concept of irrational numbers are, I'm writing it down, I'm showing it to you over here, that irrational numbers are, there are three type of numbers. There are three type of decimal numbers. First one, terminating, like 3.62. This is a terminating decimal number and it can easily be written in irrational form. This is not easily written in rational form. This is not an irrational number. Why? Because we can take out point from here and we can write it like this. Now 362 upon 100 is the irrational number. Second type of number is non-terminating. Non-terminating decimal number. Non-terminating decimal number will be, let's say a number is like this, 3.6218716789256 up to infinity. Now you cannot take out point from here because you do not know how many times of 10 multiples you have to write at the denominator. So such kind of numbers are irrational. Such kind of numbers are irrational numbers. Other than this, we also write under root 2, value of under root 3, value of under root 5 or any other prime number is always irrational. Therefore, they are non-terminating decimal numbers. Therefore, they are also irrational. Even the value of pi, that is 22 by 7. It always comes to be irrational. And when we talk about any other number, third type of numbers are non-terminating, repeating or reoccurring decimal numbers. What kind of numbers they are? You might have studied this in ninth also, like 3.621, 621, 621. You can write it as 6621 bar. That means that decimal numbers are non-terminating, but some portion of those numbers are repeating themselves again and again. These kind of numbers can easily be converted into rational form. This we have studied last year also, how we'll take x equals to 3.621 bar, then we'll take out this portion of repeating decimal portion out from decimal, just one portion of this, it will be 1000x equals to 3621.621. This will consider equation 1, this will be considered equation 2. Subtracting equation 1 from equation 2, we'll get 999x will be equals to 3618. and x will be equals to 3618 upon 999. This will be your rational form for this number. So these are three type of numbers. Over here we will study, in this revisiting of rational numbers, we will study how under root 2, under root 3, under root 5, under root 7 or any other prime, under root of any other prime number is a irrational number. So first what we will do, let's say we have to state that under root 2 is irrational. Show that under root 2 is irrational. How we will start this out? Let's say first we are assuming, or we are taking as under root 2 is rational number in a form p by q, where p by q or a by b, whichever way you want to write, where a and b are co-prime. Co-prime means they do not have any other common factor except 1. Now how we will write this out? According to the arithmetic algorithm, it will be under root 2 will be equals to a upon b. Under root 2 will be equals to a upon b. Further we can write it as under root 2 into b equals to a. Now on squaring both the sides, we'll get 2b square equals to a square. Now again through Euclid division lemma, we get to know that this a will be is a square is divisible by 2. This a square is actually divisible by 2. So this a square is divisible by 2 through Euclid division lemma. Over here the another property will come, that is theorem number 1.3. Let p be a prime number if p divides a square. This is basically a square. Again there is a misprint. This is a square. If p divides a square, then p divides a, where a is a positive integer. मीनिंग क्या है? अगर कोई नंबर a स्क्वायर को डिवाइड कर सकता है तो वो ऑफ कोर्स a को भी डिवाइड कर सकता है जब कोई a पॉजिटिव इंटीजर हो. तो we'll back to the main part which we were studying over here, that is a square is divisible by 2, मतलब 2 a square को डिवाइड कर सकता है. That means 2 can also divide a. Therefore a is also divisible by 2. AB क्या है? Divisible by 2. Next we will take, let a equals to 2c. a अगर 2 का divisible है तो a equals to 2c we can take, means वो क्या है? Even number. So for that we have taken a equals to 2c. Now a square will be equals to 2c whole square. A square will be equals to 2c whole square. Put this value in this as equation 1. In equation 1. So that will become 2b square equals to 2c whole square. That is 2b square equals to 4c whole square. We can cut this and it becomes b square equals to 2c square. Again through Euclid algorithm and theorem 1.3, we can say that b square is divisible by 2. Therefore b is also divisible by 2. Hence what we get, a and b both can be divided by 2. Now a and both can be divided by 2, but we have taken a and b as coprime. Then how can it has one more number by which it can be divided? So this is contradicting our this contradicts this is contradicting our assumption that under root 2 is rational. Therefore, we can say that under root 2 is irrational. Why it is irrational? Because of course, if a and b we have taken co-prime over here, then anyhow it can never be equals to it can never have any other factor common except 1. Now similarly you can find the show that under root 5 is irrational. Over here you will take it as under root 5 equals to a by b, then 5 b 5 under root 5 b equals to a, and you can solve it further. Proof of this. Now over here I would like to share one more property of irrational numbers. If we multiply any irrational, if we add or subtract anything from irrational number, it remains irrational. I repeat, if we add or subtract anything in an irrational number, it remains irrational. Means even if I add or subtract, let's say, if I there is under root 5, under root 2, if I subtract anything from this or I add anything to this, it will remain irrational. Both of this will be irrational. Both of them will remain irrational. Okay. Now another thing which I want to tell you, if we multiply any integer, only integer to an irrational number, it will also remain irrational. It should be integer, not an irrational number. If we multiply two irrational numbers, they could be irrational or they will become a rational number. Like if we multiply under root 2 into under root 2, it will become 2. It will become 2, which is a rational number or an integer. But if we multiply an integer to a rational number, it will always remain irrational. This will always remain irrational. I'm writing IRR for irrational. Is that clear? So this will help you to prove everything over here. You can easily prove this as irrational by this method, or first you have to prove that under root 5 is irrational, then the multiple of that is irrational, and a sum to that is also irrational. Over here in question number 3, if we, another property which I missed, if we divide a number with an irrational number, it will also remains irrational. If we divide any number with a irrational number, it remains irrational. Similarly, if we are dividing an irrational number with some integer, if we are dividing an irrational number with some integer, it will also remain irrational. If we multiply any integer with irrational, it will remain irrational. If we add any integer to a irrational, it will remain irrational. By this method, you can solve this equation number 1.3 also. Now, this is for today. You can now complete your exercise number 1.1 and 1.2, and next we will study the last exercise of this chapter. Thank you. Stay home. Bless you.